So we select our project as fake and real news detection system. So we use four different machine learning models for predictions. So I built a fake news detection system using random forest algorithm. First, I imported the required libraries such as pandas and numpys for data implementation, scikit-learn for building the machine learning model, and the matplotlib and seaborn for visualization. Next, I loaded the two data sets, one containing fake news and another containing a real news. So I labeled fake news as a 0 and the true news as a 1, and then combine both data set into a single data frame. After merging, I performed data cleaning. So I removed unnecessary columns like title, subject, and date, date. Then I shuffled the dataset to ensure randomness and remove duplicate entries to improve data quality. Uh, Next I implement the preprocessing section. So I create a function to clean the text by converting everything to lowercase, removing URL, removing biased words like routers and AP news, keeping only alphabetic characters and removing extra spaces like this. Uh, so these steps ensure the model learns meaningful patterns instead of noises. After preprocessing, I split the data into a uh, training and testing sets using 80 to 20 ratio. So and also I use maintain the class balancing using stratified sampling. Next, I built a machine learning pipeline. So this pipeline has two main components. First, a TF-IDF vectorizer. This vectorizer converts text into a numerical features and based on word importance. Second, a random forest classifier, which is an the random forest classifier is an assembler learns method that uses multiple decision trees to improve prediction accuracy. To optimize the model, I use randomized search for hyperparameter tuning. So this automatically tests the different combination of parameters like number of trees, depth, feature limits to find the best configure. So after training, I evaluate the model on the test data. So the model achieved an accuracy of uh, 0.94, so which is this accuracy is quite strong for text classification problem. And also looking at the classification report, fake news detection has high precision and good recall, and the real news detection has very high recall, meaning so most real news is correctly identified. uh, for further validation performance, I use cross validation, which confirm that the model generalizes well to unseen data. I also visualize the result using several graphs, the confusion matrix, and the learning curve, and the ROC curve. Thank you. Over to you, Samudra.
Thank you, Anjana. So here I selected support vector machine, a powerful supervised learning algorithm for classification. So SVM is a machine technique widely used for classification tasks, especially in text-based problem. The main idea of SVM is to find an optimal decision boundary called a hyperplane that separates different classes, in this case fake news and real news. It works by maximizing the margin between the closest data points of each class. which improves generalization. SVM is particularly effective for this problem because text data, when converted into numerical features using techniques like IF, TF-IDF, becomes high dimensional and sparse. SVM handles such data very efficiently and provides high accuracy. Here, data labeled fake news as 0 and real news as 1, and combine both dataset into a single dataset. And here, text cleaning, clean the text by removing noise such as punctuations, URLs, numbers to prevent any other misleadings, and then split the data sets into 80% of training data and 20% of testing data using sampling. And for the model building, use a support vector machine model with TF-IDF feature extraction. TF-IDF converts text into numerical form, and SVM finds the best boundary to separate news. Um, Here, the model achieves high accuracy on both training and testing data, showing a good generalization. Here, the confusion metric shows how well the model distinguishes between fake and real news. So through this interface, users can enter a news and get the prediction. Finally, SVM with TF and IDF provides an effective solution for news detection. Further improvements can include deep learning and larger sets. So thank you. Over to Dinity.
Thank you. I have used naive Bayes, which is a supervised learning machine learning algorithm based on probability. It applies Bayes' theorem to predict whether a news article is real or fake, and I specifically used multinomial naive Bayes model because it works well with text data and word frequencies. Before applying the model, I did some cleaning process to remove text cleaning to remove stop words and punctuations, and then first converted the data into text data into numerical form using TF-IDF feature extraction method. Um, and then in this code, I have used the following line to create the model, the multinomial naive Bayes, then train the model. Uh, Here, the model learns patterns from training data, such as which words are more likely to appear in fake or real news. After training, the predictions were made, which allows the model to classify unseen news articles. One of the main advantages of naive Bayes is that it is very fast and efficient, even for large data sets. It also performs well with high dimensional data like text. However, it assumes that all features are independent, which is not always realistic. But despite this limitation, the model achieved 93.5% of training accuracy, which shows that it is effective for fake news detection. And overall, this naive Bayes is a simple yet powerful algorithm for text classification tasks. And also, the results are visualized using this confusion matrix as well. Thank you, Rachel. Over to you.
So, good evening. My name is Rachel, and thanks for handing over the presentation to me. So, first of all, we have used logistic regression here for the classification, and logistic regression goes as a supervised learning technique, which uses techniques like binary classification, where you can classify some data into two classes. Now here, coming up to the scenario where we identify some data is real or whether it's fake, so it can go under these two categories of being true or false. So let's move into the code. So first of all, I have imported several libraries, as you can see, pandas to deal with the data manipulation and tabular data, and then we have NumPy because it's numerical operations that are involved, and re is a library which uses regular expression module for text cleaning purposes, string and warnings. And then we have also used sklearn model selection for the train test split, feature extraction, and logistic regression. So this is where we have uploaded the files, so and we can get the result that it has been uploaded here. So when we use this fake CSV and true CSV as the two CSV documents, so it prints a number of dimensions here of both CSV files, and then like the label goes as for a fake data, it would be represented as 0, whereas true data would be represented as 1. And here we using pd.concat, we concatenate or combine the fake data with true data vertically into a single data frame, as I've mentioned. And here is the final result where we get the classifications as a 0 or 1, so you can easily distinguish which data is true and which data is false. So then later we are calculating the count of missing values. So this is part of the normalization. And then we fill any missing values with the title column. We avoid any special characters or any unwanted spaces. So these are some sort of pre-processing techniques that we have involved to the process. And we have also a function called clean text. So this is where it, you convert the text to string type and to lowercase. And yeah, we remove any HTML tags that are involved and remove non-alphabetic characters, replace multiple spaces with a single space, and returns a clean data set. And we finally print the shape, that is the number of samples of X and Y. And as previously mentioned by other members, so I have also included where we have 80% for training and 20% for testing, which we call the train test split. And then we initialized using TF-ID vectorizer with English stop words, and we fit the vectorizer onto the training data, transforming it using TF-IDF features. So this is where that text features are being transformed to numerical data. And then we print the shape of TF-IDF transform training data versus transform testing data, which you can see here. And we initialize the logistic regression model with having maximum iterations of 1,000. And we train the model using TF-IDF features. So once it is successfully trained, it should deliver you a message saying model training completed. And we use the trained logistic regression model to make predictions based on the test features. And overall, the achieved accuracy level was as you can see 98%, which is kind of a considerable rate. And moving on to the function where we predict whether the news is fake or real. So we clean the input data using the previously defined text function, and then we transform it using TF-IDF features and obtain the predefined predicted label, which is 0 for fake data and 1 for real data. And you obtain the probability scores for each class and return the label and the class probability, as you can see. And then, so as you can see, the news category here is government announces a new national education reform policy today, and the prediction is saying that it's fake news. So it shows the probability levels here as well. And we have also used this pickle library for serializing and deserializing. It converts like I think Python objects, and then here we have involved to the option to open a file in binary write mode, and we serialize the data and save the logistic regression model to the file. And then you can also open another file in binary write mode to save the vectorizer, and that will be saved later. So if all goes well, it should deliver you a message saying model and vectorizer is saved successfully. So speaking about the improvements that had to be done, it would be much better if we had to, have some more data to the model. But due to the current situation, some features had to be limited. However, logistic regression is a good option when it comes to choosing whether classification of data into fake data or real data. But then again, there's always room for improvement. So further in the future, we can apply techniques like removing stop words, using engrams, and applying stemming to enhance further performance.